Good morning, student. I am Chinmoy and student profession physics. Today we will discuss a very interesting topic. We all know this topic is a vector analysis. So let's start with the topic vector analysis. That is for the class 11. I will try to continue the class in bilingual language and Bangla and English মিশিয়ে পড়াবো তোমাদের সুবিধার্থে। তো আমরা আজকে বেসিক থিংস থেকে স্টার্ট করি। So first I have a question for you. What is vector? Generally we all know a quantity having magnitude and direction is called vector. But is this definition is correct? There was some problem. Like that, if I tell you that is the area is a vector quantity. So this is the area, length into breadth. That means common people or generally students answer that is it is a scalar quantity because that is no area at all, direction at all. In case of time, the time is a direction from past to present and present to future. So time is a direction also and it is a magnitude also. But time is not a vector quantity. That's why there was some problem in definition here. So need to know where from this direction start and how many direction in case of vector. অর্থাৎ ভেক্টরের কতগুলো দিক হতে পারে, মান ও দিক। সাধারণত আমাদেরকে বুঝতে হবে, আমরা যদি শুরু করি কোঅর্ডিনেট থেকে, অর্থাৎ আমরা যদি ওয়ান ডাইমেনশন স্টার্ট করি, 1D motion structure, that means it is your dimension, it is origin, it is positive x direction, it is negative x direction. So you have two possible direction along x and along minus x. That means it's the direction. In case of two dimensions case, you have the space like that. Try to understand from here. That is x, that is y, that is minus x, and that is minus y in origin. That means you have first quadrant, second quadrant, third quadrant, and fourth quadrant. That means you have four different quadrants to represent this space. Suppose we have a point here that is called P point, having coordinate x, y. We x, y কিভাবে represent করব? First we move towards x direction and then move towards y direction. That means we have a direction from O to P. That means try to understand O to P is a vector quantity. That's why vector is simply the presentation of a point with respect to another point. It may be from origin. Generally, a vector represented by, suppose it's the vector is called a position vector. Position vector, বাংলাতে বলা হয় স্থান vector, that is called, it has a magnitude and has a direction, unit direction. That means every vector having a magnitude and having a direction. And it is basically unit direction. So every vector associated with the magnitude and as well as direction. Now we have a question. What is the direction and how we represent the direction? Basically, we discuss firstly about 1D and 2D, then we go for 3D in my class. Actually, we have three basic unit vectors. We have three basic unit vectors. That means we have three basic directions. Along x, it is called I hat or I cap. Along y, it is called j cap. And along z, it is called k cap. That means we have three fundamental vectors or unit vectors. Along x, it is I cap. That means unit space, it is I hat. Opposite direction, it is minus I hat. Along y, it is j cap. And along J, we discuss on our next topic, that is in 3 dimensional vector. First, we try to understand the 1 dimensional vector. Suppose we move from O to A, that is having magnitude x. So what is the vector? The vector is OA vector, and that is x I hat. Why? Because x is the magnitude, that is weight, and I is the direction. In case of 1D. What is the case in case of 2D? In case of 2D, we move first along x and then along y. That means first we move along x, that is x I cap plus. Then we move along y direction, that means how many magnitude? Y magnitude, that means it is y j. That is standard O to P vector, or in 2 dimension the position vector is x I cap plus y j. As it is a 2 dimension vector, that's why 2 unit vector associated with it, I cap and j. In case of 1 dimension vector, it is only I cap, so it is a vector. And we represent the vector in 2 dimension with a combination of I cap and j cap must. And next, what is the magnitude of those vectors? That is very easy. That is, from this triangle, we apply the Pythagoras formula, that is R by 2 magnitude, or simply R is equals to, that is height, is equals to base square plus normal square, that is root over of x square plus y square. That is fundamental representation of a vector in 1 dimension and in 2 dimensions. Now, finally you can write that x I cap plus y j cap is equals to root over of x square plus y square into n, where n is the unit vector of OP. So we can find out the unit vector also like that. N equals to xi plus yj divided by root over of x square plus y square. So we have 3 parts in this picture. That is, first, the dimension is 1 dimension, it is 2 dimension, it is the basic vector representation, it is the basic unit vector. So you have to know these 3 points, that is vector along x, vector along y, and vector along j. And fundamentally, a 2 dimension vector can be represented as xi plus y delta. 1 dimension vector can be represented as x I hat. Okay? So it is clear for 1 dimension and for 2 dimension and how we represent the vectors. Okay. So we continue the topic, that is vector representation. How can we represent the vector? Simply, a vector is a quantity having the magnitude and a direction. That means if you have the scale, then it is a magnitude, that means 37, and a direction from, if you consider that the initial point it is final point, that is the direction along upward, and if it is the initial point, then the direction along the downward direction. Then every vector, if you check the initial and final point, then only direction changes, but the magnitude of the vectors remain unchanged. Now, what is the case in case of 3D? We all know that is, we have 3 fundamental vectors: I cap along x, j cap along y, and k hat along j. So, in case of 1 dimension, we have 2 space, that is along x, along y, is 2. In case of 2 dimension, we have 4 space, all sine, tan, cos. So, what happened in case of 3 dimension? That is very interesting for 3 dimensional graph. In case of 3 dimension, we draw a fundamental figure. That means like that. Try to understand the figure first, because this figure is very fundamental. For representation, just draw the figure step by step, such as you can also do it. just like put 3 box and this join it. Look at the figure first. It is basically the octane diagram. It's a very interesting figure, octane diagram. To fill this figure from your point. That means here you have 3 cube here, 1, 2 and 3. But actually in this figure we have 8 cube. Just look at this figure. If we consider it is x direction, it is y direction, it is z direction, then we have the number of cube like that. It is first cube, second cube, third cube. It is fourth cube. Just it is a fifth cube. It is sixth cube, and just below the third, here is a seventh cube, and in front of just below the 4, it is a 8. That means total 8 space in case of 3-dimensional figure, and it is the origin. That is called octane diagram. It's very interesting figure. And in case of 1 dimension, you have 2. In case of 2 dimension, you have 4 space, and in case of 3 dimension, you have 8 space. I mean, number of space is equals to 2 to the power dimension. So in case of 4 dimension space, you have total 16 space. On our another video, we will try to discuss about the 4 dimension space. Generally, we discuss here 3 dimension space. That means in case of our space, we have 3 coordinates, that is x, y, and z. We can easily represent like the figure that is x, that is y, and that is z. That means if you consider any like the books, suppose it is a books, then we have a x direction, it is y direction, and it is z direction. Every corner of your home, তোমার বাড়ির প্রত্যেকটা কোণায় একটা ডাইমেনশন আছে, that is along x, along y, like that, along x, along y, and along z. It is minus z, it is plus z. That means we have positive z and we have negative z. Now how we represent the point in this space? Suppose we have a point x, y, z. Then how we can go from it? Like that. First we move from along x, then we move along y, then first O to A, then A to B, and then we move up to Z direction, then up to P point. The coordinate of the P point is x, y, z, typically. So representation of the P point with respect to O, that is very simple. O to P. So O to P is a vector coordinate. We represent this vector on this figure also like that. Suppose we move along x, magnitude small x, then we move along y, and then finally it is z. So the point is here, like the point is P, x, y, z. That means we have a vector, we have the position vector, xi plus yj plus zk. Initially we move at first along x and then along y, and x means xi, then along y it is yj, and then along z it is z. So in case of 3 dimension, the presentation is very simply xi plus yj and z. Now we try to discuss the magnitude of this vector. We represent the vector very simply. First we represent the vector. Suppose you have a point 2, 3, y. Then the vector is 2i plus 3j plus 1k. Just simply. Okay. Next try to find out the magnitude of the vector. Okay. Okay, student. So we have a task now. How can we find out the magnitude of this vector? That is R vector. Simple R vector means O to P vector. That is R vector. To find out this in this space, that is R vector. We represent this space only here. Then first try to draw a line O to B. We have the angle here is 90 degree. Generally, this angle looking less than 90 degree, but actually it is 90 degree because it is the angle between x and y. So, if it is x, it is y, then we have OB is equals to under root of x square plus y square. It is OB. Now, this angle is also 90 degree. So, we have the height, that is O to P, Otibhuj is equals to Bhumi square plus Lamba square, that is OP is equals to OB square plus BP square to the power. So what is BP? BP is Z. So x square plus y square plus z. That means very simple, OP magnitude is equals to, that is R magnitude is equals to x square plus y square plus z square to the power. So a vector, 3-dimensional vector R is xi plus yj plus z. It is the vector, presentation of vector, and it is simple, the magnitude. So try to represent the vector at first. Vector quantity having magnitude and direction is not correct. Practically, vector is a representation of a point with respect to another. And every time, vector needs at least one unit vector. That is either I, either j, or either k. You may combine this unit vector, that is ij, that is xy plane vector, jk, it contains on yz plane, and ik, it is on xz. Or it may be in the combination of I, j, k, that is the actually 3-dimensional position vector or 3D space vector. This space vector is very simple, xi plus yj plus zk. So we represent this vector by the proper unit vector, fundamental I, j. Hope you have no question up to this. Now we go to our next step, that is a conceptual problem here. I discuss a problem here. Suppose there is a question, that is very simple question. The question is, represent, very common question, the point P 12, 3, minus 4 with respect to origin, or 12, 3, plus 4. So first draw the figure. It is x, it is y, it is z. So first we go 12, then we go 3, and then we go, suppose it is 4, and we have the vector, that is O to P, that is R vector. That means R vector is equals to, what is the result? First 12, then 12i, fundamental class, 3 plus 3j, and 4, that is 4k. That means 12i plus 3j plus 4. It is the vector. So what is the magnitude? The magnitude of the vector is mod r is equal to root over of 12 square plus 3 square plus 4 square. That is called 144 plus 9 plus 16, that means near about 169, that is equals to 13 units. That means O to P measurable value is 13 units, and the vector is 12i plus 3j plus 4k. So what is the unit vector also? So we have the unit vector here, n hat is equals to vector that by mod of vector. What is the unit vector? Unit vector is a vector whose magnitude is 1, but it has a direction. That means very simple, the unit vector is 12 by 13i plus 3 by 13j plus 4 by 13k, and the mod of unit vector is equals to always 1. That means root over of 12 by 13 square plus 3 by 13 square plus 4 by 13 square, that means 1. That is complete problem. How can you represent the vector, the magnitude of the vector, and the unit vector also. So, most important 3 questions from vector: how we represent the vector, how we find out the magnitude of vector, and how can we find out unit vector. Now, I have a question for you. That is very interesting question. Like that. Suppose I have a question for you for my next video. That is, if you have an unit vector, capital A, 0.3i plus aj plus 0.4k, then find out the value of small a here. With an assignment for you for my next class, and on my next class we will discuss how to add the vector and how to subtract the vector, about the resultant vector, and is there any another type of algebra for the vector? Yes, vector follow a basic algebra because it contains 3 unit vectors: I hat, j hat, k hat. That means 3 variables: I hat, j hat, and k hat. And combining these variables I hat, j hat, and k hat, we have a different types of algebra, and we proceed on this algebra on my next class, that is vector sum or vector addition. Okay, so thank you to all of you.